Today we are going to be reviewing Chapter 4. First we start off by graphing using a table, and with a restricted domain. So it says graph the function with the given domain, then identify the range of the function. So first I'm going to make a table just like it says, an XY table. But it says our domain can only be certain numbers. This symbol, like an L, stands for less than or equal to 0. If it was flipped the other way, that would be greater than. So less than 0 would be our negative numbers like -1, -2, -3. So we're going to plug these into this equation for the letter x. So first it says 3 minus 2 times x, which is 0. Now if we follow the order of operations, we are multiplying here, so 2 times 0 is 0. So 3 minus 0 is still 3. Then if we plug in a -1, 3 minus 2 times x, which is -1. Multiplying first, -2 times -1 makes a +2, so 3 plus 2 is 5. Then plugging in a -2, 3 minus 2 times -2, all I'm doing is plugging in our number for x. A negative times a negative makes a +4, and 3 plus 4 is 7. Well, you might see our pattern 3, 5, 7, next would be 9. So if we plot these points, x and y, first x is 0, so we didn't go left and right, we just went up 1, 2, 3. That's that point, 0, 3. Then this point, -1, 5, x is -1 to the left, up 5. Then -2 to the left on my x-axis, and then 7 is right at the edge there. And -3, 9, I can't plot that one, it doesn't go up to 9 on my graph. Now this is one where our x's, we said, had to be less than 0, so they had to be on the negative side. So we didn't want to graph anything on the positive side, so our line makes a ray, starting here and only going to the left. We cannot go to the right to the positive side. Then it says identify the range. Our range is our y values. Well, if x had to start at 0 and only go down, y had to start at 3 and only go up. They went positive. So not less than, but instead greater than or equal to 3. Let's do another one just like it, except this time our domain is restricted on both ends. X has to be, like an L, less than or equal to 6, and on this side, greater than or equal to -2. So in my table, xy, x has to be less than 6, so 5, 4, 3, 2, and so on, but it has to be greater than -2. So greater would be towards the positives, -1, 0. We need to move these down just a little bit, oopsies, because we need to fit a 1 in there as well. 2, 1, 0. From -2 all the way to 6. So if we plug these in, our equation right here, we have -2 times x. First I'm going to plug in a 6, and then add 5. Well, -2 times 6 is -12. -12 plus 5, there's more negatives, should be a -7. Then if we plug in a 5, -2 times 5 plus 5, I'm just using the same equation. Well, -2 times 5 is -10. -10 plus 5 is -5. Then if we plug in a 4, -2 times 4 plus 5, well, -2 times 4 is -8, plus 5 is -3. You might be able to see the pattern. We're going down by 2's. So 7, 5, 3, then would be -1. 2 more, adding 2 more would be a +1, plus 2 more would be a +3, a +5. Where are we here? These two go together, these two go together, these two go. So then we have a +7, and then a +9. So if we graph these, x is 6, y is -7, so x is 1, 2, 3, 4, 5, 6, and -7 is right on the edge. Oops. Then our next point is 5 to the right. 5 is right there. And negative 5. Then 4 on my x-axis to the right, 1, 2, 3, 4, and down 1. Oh, sorry, down 3, 2, 3, that makes sense. I was going to say that wouldn't form a straight line. Then 3 to the right, 1, 2, 3, and down 1. X is negative, or y is negative 1. Then x is 2, y is 1. X is 2 to the right, y is positive 1. Then 1 up 3. 0 up 5, negative 1 up 7, negative 1 up 7 is right in the edge there, and our last point, negative 2 up 9, would be off our graph, but this forms a ray, or a nice straight line. There are no arrows on either end. And then last, our range. Our range is our y values. Well, if y had to be less than 6 here, y had to be, these numbers are now greater than, because they go towards a positive, greater than or equal to negative 7. But our y's on this end, they had to be, our x's had to be greater than negative 2. Our y's also had to be, this is a positive 9. These are just connecting to make sure those two numbers went together. These are all positives. These are less than 9, so less than or equal to 9. Next, we learned how to find x and y intercepts for a graph. We are going to do that. Remember drawing our little squiggle. First, we're going to find our x-intercept, and then our y-intercept. To find our x-intercept, we plugged in y is 0, and to find our y-intercept, we plugged in x was 0. So first, if I plug in y is 0, we have 6 times 0 plus 3x equals 18. Well, anything times 0 is 0. So we have 3x equals 18. And divide by 3 to get x by itself. 18 divided by 3 is 6. Over here, plugging in x is 0, we have 6y plus 3 times 0 equals 18. Anything times 0 is 0, so we have 6y equals 18. And then divide by 6. 18 divided by 6 is 3. So we're going to plot those 2 points, and we're done. So our y-intercept is 3, up 3, and our x-intercept is 6. I don't know why I did those in the wrong order there. And please don't just do this. Make sure it goes all the way through on both ends. All the way through, and we can put arrows on the end to show that our graph could go further. This is the same type of problem, finding our x and y intercepts, but it's more of a word problem. It says you are planting an ornamental garden that has a total area of 200 square feet. There are 2 sizes of ornamental plants you have chosen for your garden. Each small plant requires 4 feet of space, and each large plant requires 8 square feet of space. This situation can be modeled by the equation, 4x plus 8y equals 200. Where x is the number of small plants and y is the number of large plants to be placed in the garden. Here's our keyword, find the intercepts. That's our x-intercept and our y-intercept. And then graph the equation, and what do the intercepts mean? So for our x-intercept, y is 0, and for our y-intercept, x is 0. So first, if we're plugging in y is 0, it says 4x plus 8 times y, which is 0, equals 200. So that's just 0. We have 4x equals 200. Divide by 4. 200 divided by 4 should give us 50. And same thing over here, plugging in x is 0, so 4 times x, which is 0, plus 8y equals 200. Well, that's just 0. So we have 8y equals 200, and divide by 8. 200 divided by 8 should give us a nice 25. So because both of these are positive, I'm going to just make this my x-axis and this my y-axis. X and y. And I'm going to have my lines, let's say, go by 5s so that we can get to 25 and to 50. So I'm going to only label every other one so that my numbers fit 10, 20, 30, 40, 50, 60. That should be plenty. And going this way, this would be 10, 20, 30, 40, 50, 60. And we could have used a little bit more of our graph maybe, but that's okay. So on my x-axis, I need to graph 50 right here. And on my y-axis, 25, which is right there. And draw a line between them. So it says down here, what are 3 possible numbers of small plants and large plants that you could plant in the garden? Now, x, where does it say up here? X is small and y is large. So x down here, this is small plants, and y is large plants. So at this point right here, that is a combination. We could have 25 large plants and 0 small plants. Same with down here, we could have 0 large plants and 50 small plants. Or we could have some combination in between here. Now I would look for a point where we cross at a nice number. Now this graph isn't perfect, but try your best. Oops. I would say that as I follow along here, this might be a good point. Oops, where's my pen? Otherwise, maybe this might be even a better point. Somewhere along here where you can figure out a number of plants. There could be multiple points on here that you could actually use. So pick one where it crosses a nice number. I'm going to pick this one where I have the arrow here. This would be 20 small plants. And oops, right on that line there, between 10 and 20 would be 15 large plants. Again, you could have used any of those other points, but they only wanted 3 possibilities. So this is 1 possibility, 2 possibilities, and 3 possibilities. Then we learned about slope using our slope formula, which is y2 minus y1 over x2 minus x1. This also is on the wall. For those of you who don't remember this, that's okay. You don't need to memorize it. Our points, we need to label x, y. This is my first point. X, y, this is my second point. And plug them in. It says y2 minus y1, so y2, which is 8, minus y1, which is a negative 2. 2 negatives make a positive. And then on the bottom, x2 minus x1, we have negative 8 minus x1, which is a negative 10. Again, those make a positive. 8 plus 2 is 10. And on the bottom, negative 8 plus 10. There's more positives. There's 2 more positives. And if we simplify this even further, we can divide by 2. And we get 5 over 1, or just 5. The second one, we can also solve using the same slope formula that we did up here. I'm going to label my points x, y first point, x, y second point. And they're telling us our slope, so we really need to find out what this missing value is. So our slope is 5, and we're going to set that equal to y2 minus y1, so y minus 9. On the bottom, x2 minus x1, so negative 1 minus a negative 3. Again, those 2 negatives make a positive. And we can simplify this. Y minus 9 we can't simplify, but negative 1 plus 3 is really 2. Now if you want to solve this, you can solve this either by cross multiplying, or if you would like, we just need to get y by itself. The opposite of dividing by 2 would be multiplying by 2. So 2 over 2 cancels out. We have y minus 9 equals 10. And then add 9 on both sides. 9 plus 10 is 19. If you did this, I'm going to rewrite this over here. 5 equals y minus 9 over 2. If you put this over 1 and cross multiply, you would get the same answer. Alright. Next it says put the equation into slope-intercept form. That's the form y equals mx plus b, and graph it. So if I solve this for y, I need to move the x's to the other side. I'm going to subtract 2x. So you have 3y. And write your x's first because we want our x's first in our equation. Negative 2x and then minus 6. And then last, the opposite of multiply by 3 is divide by 3. Divide every single term by 3. Now 2 over 3 we can't really simplify, just leave it as 2 over 3x. Minus 6 divided by 3, which is 2. Now we need to graph this. B tells us where to begin our graph, and M tells us how to move. So we're beginning at negative 2 on our y-axis. So right here. And our slope is rise over run. We can't go up because it says it's a negative 2, so instead of going up, we're really going down 2. And positive 3 is to the right. And then down 2, 3 to the right. The opposite of down and right would be up and left, so we can go up 2, 3 to the left as well. So there's that equation. Put our arrows on the end. And then the second one, solving this one for y as well. This is a 1x. I'm going to move that to the other side by subtracting 1x. Now this is a negative y. We need to write that negative there. It's not just y. Write your x's first, and then plus 6. And then last, this is a negative 1, so the opposite would be, opposite of multiply is divide by negative 1. We have y equals now a positive 1x and a negative 6. 6 divided by negative 1 is negative 6. So when I graph this, I'm beginning at negative 6 on my y-axis right here. And my slope is really a fraction 1 over 1. Rise 1, run 1. Rise 1, run 1. Or down 1, 1 to the left. And there is our equation. We have graphed in the function form y equals mx plus b. Here is a direct variation equation. It is the same as function form y equals mx plus b. The only difference is this graph goes to the origin, meaning it's beginning at 0. So they want an equation in this form. So the only thing we really need to find is our m, our slope, right here, because x and y are part of our equation. So we have 2 points. We can just count our slope. Rise, 2, and run, 1, 2, 3, 4. Now we can simplify 2 over 4. If we divide by 2, we get 1 over 2, or 1/2. So our equation would be y equals 1/2 x plus 0. Here it says, given that y varies directly with x, write a direct variation equation that relates x and y. Well, in our equation that we just looked at up here, y equals mx, there really is no plus b because it's really just 0. So if we want to find m, our slope, we can just take x and y and plug them in, or solve this for y, or solve this for m first. I'm going to solve for m, meaning divide by x. So we're just going to take y, and we're going to divide it by x. So y is negative 4. We're going to divide it by negative 18. 2 negatives make a positive, and we can divide by 2. We would get 2 over 9. So our m, or our slope, is 2 over 9. So our equation would be y equals 2 over 9x. And if you want, plus 0. The last 2 problems, hopefully you remember, this is from 4.7. We did one on our warm-up for this lesson as well. Compare the graph given to the graph of f of x equals x. Now this graph is really our parent function, and f of x or g of x or h of x is really just a fancy way for saying y. So that's our equation. We need to compare to our parent function. So we're going to graph our parent function. This is 1x really plus 0 on both. Beginning at 0, and our slope is 1 over 1. Rise 1, run 1. Or down 1, 1 to the left. Again, this is our parent function. We're always going to compare to that line. While we're at it, I'm going to graph this parent function on my other graph as well, starting at 0, and my slope is rise 1, run 1. And same thing over here as well. This is one that you could maybe memorize to make your life a little easier. There's our parent function. Now we need to graph whatever other function they give us. This first one, they give us y equals 1x plus 4. So that is in the form y equals mx plus b. So we're beginning at 4. 1, 2, 3, 4. And my slope is 1 over 1. Or down 1, 1 to the left. And draw your line through it. Now these two lines you can kind of tell, but we need to compare them anyways. We're going to compare always our m, our slope, and our b, our y-intercept. So our slopes, you can tell just by looking at them that they have the same slope. Another word for that would be parallel. So when we're comparing, we're always going to tell me, is it something the same or is it different? But if it's different, you need to tell me how it is different. Okay? So these were the same, slope, we're good. But now our b's, our y-intercepts, these are really crossing our y-axis at two separate points. So we need to write that different y-intercept. Again, I'm shortening. And if something's different, we need to say how it's different. Compared to our parent function right here, this new graph is moved up 1, 2, 3, 4. So you could say moved up 4 units. You could say translated up 4 units. You could say shifted up 4 units. But you need some word that tells me that it's moving. It's going up 4 units. It didn't go down 4 because we're comparing our new red line to our old parent function. Same thing on this second graph. We need to first graph it. So this is our equation, y equals negative 2x. As our slope, we could put that over 1. Plus 0, there's nothing there, so we're starting at 0. And our slope is negative 2 over 1, or down 2, 1 to the right. Positive 1 is to the right. The opposite of down and right would be up and left. Make sure that when you graph this, you have a negative slope. This said it was negative. Our slope person would also be walking down a hill. Negative. So when we compare these, just like before, we're going to compare m and b. So first our slopes, you can tell just by looking at them, these are not the same slopes like the other one was, so they are different slopes. If something is different, we need to tell how it is different. Well, if we're always going to go sledding down this hill, here's my sled, my person on it. If I'm always going to go sledding down this hill, but now I go sledding down this new hill, this one is a little bit steeper. So you could use the word steeper, or you're going to go faster sledding down that hill. But the hill is also going in the wrong direction, which we call a reflection. It is flipped the wrong way. And then last, our b is comparing our y-intercepts. These both cross at the same point right there, so you can just say the same y-intercept. And that's it. Make sure you include all of those words when you are comparing our two lines.